Alkanes can be obtained in a laboratory either from unsaturated hydrocarbons, alkyl halides, or carboxylic acids. Let's look at each one in detail. Unsaturated hydrocarbons, like alkenes, react with hydrogen in the presence of finely divided catalysts, like platinum, palladium, or nickel, to form alkanes. As this reaction involves addition of hydrogen, it is called hydrogenation. The surface of these metals absorb hydrogen gas and activate the hydrogen-hydrogen bond. The reaction using platinum and palladium can be catalyzed at room temperature. However, the reaction using nickel as a catalyst requires relatively higher temperature and pressure. For example, ethene on hydrogenation in presence of catalysts such as finely divided platinum, palladium, or nickel gives ethane. To obtain alkanes from alkyl halides, we can either use the reduction method or the Wurtz reaction. Alkyl halides on reduction with reducing agents such as zinc-copper couple in ethanol or zinc and dilute HCl gives alkanes. For example, ethyl iodide, when reduced by using zinc-copper couple in ethanol or zinc and dilute HCl, gives ethane. Now let's see how to obtain alkane from alkyl halides using the Wurtz reaction. Alkyl halides on treatment with metallic sodium in presence of dry ether give higher alkanes with even number of carbon atoms. This reaction is known as Wurtz reaction. For example, the reaction of bromomethane with sodium metal in presence of dry ether gives ethane. It is important to note that when two different alkyl halides are taken, then a mixture of alkanes is produced. For example, the Wurtz reaction of mixture of methyl iodide and ethyl iodide forms ethane, butane, and propane respectively. As alkanes have close boiling points, it becomes very difficult to separate them from the mixture. Hence, this method is not suitable to prepare the alkanes with odd number of carbon atoms. Now, let's see how alkanes can be prepared from carboxylic acids. Sodium salts of carboxylic acids on heating with soda lime give alkanes with one carbon atom less than the parent carboxylic acid. Soda lime is a mixture of calcium oxide and sodium hydroxide. As this reaction involves the elimination of carbon dioxide from a carboxylic acid molecule, the process is known as decarboxylation. For example, sodium propionate on heating with soda lime gives ethane. Coal-based electrolytic method is yet another method to prepare alkanes from carboxylic acids. This method involves the preparation of alkanes with even number of carbon atoms through the electrolysis of aqueous solutions of sodium or potassium salts of carboxylic acids. For example, the aqueous solution of sodium or potassium acetate on electrolysis gives ethane. The mechanism of the reaction can be understood through the following steps. At anode, the acetate ions in the solution lose electrons at the anode and form acetate free radicals. The acetate free radical lose carbon dioxide molecule and thus form methyl-free radicals. The methyl-free radicals further react and form ethane gas. At cathode, water molecules accept the electrons and split up into hydroxyl ions and hydrogen-free radicals. Two such hydrogen-free radicals combine together and form hydrogen gas. Thus, in coal-base electrolysis method, alkane is produced at the anode.